Hi everyone, and welcome back to the third video in our series, Music and Patterns in TidalCycles. So last time we covered a bit on melodies, we covered how to create notes and chords, we did some things with the super piano synth, and we also talked about how to modify patterns and transform them. And in the middle of all that, we talked just a little hint of music theory. Now, in this video, we're going to do more with functions and transformations that can change your patterns and add more variation. We're going to deal more with patterns and how to modify them with other patterns. And we're going to, by the end of this, create a little bit of an example that falls into the sort of broader chiptune genre. One of the other things we're going to introduce is Euclidean rhythms, which are a really nice way to get variation within your melodies and your percussion. So the very first thing we're going to do is play the superchip synthesizer. So that by itself doesn't sound great. It has almost the opposite problem of the super piano synth in the last video, where we had to make the super piano synth sustain in order to make the notes sound like the kind of floaty piano-y notes we're expecting. In this case, we need to make it less long. We need to make the release of the note faster. And as you can tell by the way I emphasize that word, it's actually another modifier, another adjective called release. So if we try this now, that's a little more along the lines of what we want for if we want to do a fast-paced little melody. Now, to increase the number of notes in this pattern, and so yet again, we've gone back to doing the patterns with the sound on being the source of the main pattern, the thing that's that's feeding directly into the dollar signs. And we're letting the notes be a modifier, which means it comes after one of the hash marks. And we'll talk about why we're doing that in a second. And so a Euclidean rhythm has this, you write them like this. And the way you read it is the first number is how many beats per cycle, but the second number is the pulse of the cycle. And the meaning of this is we want to spread 7 beats as evenly as possible across a pulse of 8. Similarly, if we put 5, that would mean 5 beats as evenly as possible spread out across a pulse of 8. And so let's try this quick. So the advantage there is it's not a flat rhythm. It's a nice way to get a rhythm that makes sense, is a little jammable, something that you could even dance to. It's really common to find rhythms like these in music all across the world throughout human history, with varying numbers of beats across different pulses. Now, one of the cool things here is that this is a pattern. This is a pattern within a pattern. The same way we could nest patterns within each other to have, things changing and have groupings within the parts that are changing. We can do a thing here where the number of beats per cycle is actually changing. So on one cycle, it'll be 5 beats spread across a pulse of 8, and the next it'll be 7 spread across a pulse of 8, and just kind of going back and forth. So let's just listen to that quick. So we can add just a little more variation even still into this. And we're going to, there's a third parameter that we can optionally add here into the Euclidean rhythm. And this is going to change kind of a rotation, almost like where it starts relative to the cycle. And so if we do something like this, then so it will take a number of cycles for this to actually come back around to the beginning, because it's going to need to, it'll be in the first cycle, it'll be 3 and with an offset of 0. The second cycle will be 5 with an offset of 1. The next cycle will be 7 with an offset of 2. The next cycle after that, it'll be back to 3, but with an offset of 3, 5 with an offset of 4, and just continuing around. And so we've got a decent amount of variation in our pattern right here. But we're just playing the same note over and over again. So now we're going to talk about how patterns, modifying patterns, merge with your main pattern. And so we finally have a pattern here inside one of our adjectives, one of our modifiers. And we have 0 and 1. Now, this is going to be a little different than things we've seen before. Basically, the way this works is if we had things flipped and the N01 was to the left of the hash marks, not to the right, that would be 2 notes. One that's 0 and one that's 1, basically C and C sharp. It would just play C, then C sharp. Okay. Well, that's not what happens here. What actually happens here is that we have divides basically the pattern in the cycle in half. So the first half of the cycle corresponds to 0, and the second half of the cycle is going to correspond to 1. So it changes the notes of the beats in the first half of the cycle to be 0, and the notes of the beats in the second half of the cycle to be 1. So we can hear that division here. And let's go ahead and change that so that it's the notes are a little further apart now. It's a little easier to hear. Okay, so that's how we can have changing notes and be changing the rhythm of the instrument at the same time as each other. And there's some advantages to doing things this way, namely that we can keep the same overall rhythm as set by the pattern, the Euclidean rhythm of the superchip. And then we can also set a varying pattern inside the description of the notes, the pattern of what notes are going to get played. So to do that, let's go ahead and okay, so that's going to be, so now we're going to be dividing the patterns into fourths. And so on the first cycle, the cycle is going to be cut in fourths, with the first fourth corresponding to the note F, the second fourth corresponding to the note A, the third fourth corresponding to the note C, the fourth note corresponding to the note E, and then whatever notes are happening with the synthesizer and how they lay out across that, they're going to get mapped accordingly. And we're alternating between that and then D, G, E, C for the second one. So let's hear this now. So that's already, I think, more interesting. But we can keep pushing further on the idea of modifying the patterns and using pattern modifiers, I should say. And one of those is we're going to introduce a new modifier called voice, and voice kind of changes the sound of the synthesizer. In particular, it just changes sort of the shape of the chiptune kind of instrument. So let's say we'll do split into thirds and say 0.3, 0.4, and 0.5, and let that modify things. And let's listen to that. So the notes keep being, in tune, but the instrument is changing just a little bit, and that's adding some extra variation while still keeping this underlying melody that we've been working on. Now, to change things even more, we can also pattern the release. So we can have the notes vary in length across from each other. So let's try something like this. So we're getting even more variation across the patterns. And I think it's time to start introducing some more transformations. So this is one that I am very fond of called Stutter. And what Stutter does is that it creates essentially an echo. And in this case, it will create 4 echoes. It will then make each echo 60% as loud as the previous one so that they get quieter and quieter. And we need to also give a timing. And since we're doing a pulse of 8, I'm just going to go ahead and say to separate things by an 1/8. And it'll create a nice little overlapping sound. And one of the fun things is that some of these, you can actually pattern other things within here. So the number of echoes that are happening, you can actually pattern that so that in the first half of the cycle it'll be 2, and the second half it'll be 4, which changes sort of the shape even more of how the melody sounds. Now, from here, I want to add one more thing, which is, so in the last video, we saw the transformation sometimes, which basically let us apply a transformation on a pattern half the time. And this time we're going to use sometimes again, but in a slightly different way than we did before. And we used this pipe plus before to increase the melody by a full octave in the previous video. This time we're going to use it to actually change something about the parameters, the modifiers of the pattern. So if we say pipe plus voice 0.2, what this means is that half the time, what this means is that each note has a 50% chance of having its voice shifted by 0.2 up. And this means that some of the notes are going to get even more of a variation in shape. And let's hear that. Okay, so I think that's working pretty well. And from this, we can also do a variant of a trick we saw in the last video, where in the last video, we took basically what was almost like a baseline of chords as sort of an underlying structure, and then we arpeggiated to give us a melody on top of that that was kind of compatible and sounded good with it. Now, I said in the last video that we were going to take a little shortcut rather than just copy pasting all the time. And we're going to get into the fact that Tidal, this is a programming language that's underlying it. The programming language, as I mentioned in the first video, is called Haskell. And so we're going to create what's called a variable. And variables in any programming language are just a way to give a name to something you want to use again later, a way to name it, and so that you can continue to use it, so that if you change it, it can be used across all the it can be changed across all the places it was used successfully and accurately. So we're going to create a melody variable, and we do it by saying let melody equals, and let me just copy this over and replace this whole expression here with melody. And just like starting the music, we're going to hit Control and Enter to run the setting of the variable, the creation of the variable, and now we can say now this is going to make it easier if we want to make our lower, slower melody. And so we're using again our old friend slow 2 to drop things down a bit. We're going to say melody, and then we're going to change the release so that it's a little bit longer. Let's say a full release of 0.8, and then let's keep the same kind of voice pattern that we were dealing with. Okay, we need to drop this like an octave, right? And we can do that. We can do the same thing we've seen before of, there we had our pipe plus before, now we can say pipe minus, and how about now? Let's bump up that release just a little more. And let's have it playing along with our melody now. Not bad, but there's a few things that we're going to do to create some more variation that'll be nice. One thing is, let's actually reverse it And I don't mean reversing the sound. We'll get to how to reverse sound so you can play things truly like the sound backwards. But this is going to be reversing the pattern. So the pattern will play, instead of forwards, it will like flip around its shape in time and then play it the other direction. So now we can have now it feels like it lines up a little less neatly, which I think is helpful for keeping it to sound like there's still variation and hide a little bit that the bass is just a transformation of the melody. I'm also going to introduce yet another thing that I think is pretty fun, and we're going to use a transformation called jux. So jux stands for juxtapose, and what it's going to do is apply transformations differently in your left and right ears. It's going to take a transformation and put it in the channel for your right ear, but not in the left ear. So here we're going to drop another octave in just the right ear. So now if you hear this, so that's kind of fun, but what I happen to like is having things rotate around your head, kind of. And the way we're going to do that is with another modifier called pan. What are we giving to pan as an argument, though? Well, this brings us to something called continuous patterns. So before, we have been dealing with patterns where when we've been dealing with modifier patterns, we've had it talk about, if we had N01 as our notes pattern, we're dividing the pattern in half, we're dividing the cycle in half, and then 0 applies to the first half and 1 applies to the second half. Continuous patterns take on different values as far as you can divide time, and they're really useful if you want something to be changing for every single note in the main pattern. Every event of the main pattern is going to take on different values from each other because we're sort of having a smooth function in time. And what's the smooth function in time we're going to use? A sine wave. So, and we're going to slow it down a little. But the sine wave, if you've never seen one before, it's the little curl back and forth, it goes up to a hump, comes back down, beneath the x-axis, goes back up again, and it's one of the things that helps define, basic sounds. Like a pure tone is just a sine wave, except that here we're going to use sine waves to control something else about our sound. And because sine waves are kind of like, you can think of them as describing points on a circle, it's going to help give us this fun little circling effect around our heads. Actually going to speed that up just a little. Okay, so that's another nice little effect. I happen to be kind of fond of that one. And now I'm going to go ahead and grab some other things that I tried here. Just to add to this more. And so let's listen to this now. All right, so the only thing we're kind of missing right now is some actual percussion. And I'm going to copy and paste this over because it's just another application of the things we've been doing, except with a new synth. And this one is called the supernoise synth. And the idea here is that old chipsets had basically just kind of a crunchy static sound that they used with a really small release in order to sound kind of like explosions, or even a smaller release you could make it sound like percussion. And so that's what we're going to do here, and we're sticking to the same Euclidean rhythm, doing 7 beats over 8, and we're doing a shift of 1 and 3 just to give it just a little variation. And we have to shift it down a lot in terms of notes to make it sound, kind of heavy, kind of drummy. But now if we combine all these elements together, so that's the end of our example, and we've talked about, so just to reiterate what we've talked about how patterns within modifiers change the overall pattern. We've shown a couple of more modifiers we didn't have before, like voice. We've also shown how to use a variable to simplify things so that you can more easily build different parts of the song off of the same underlying rhythm. And we've talked about continuous patterns, which let us do things like have the circling effect around our heads. Now in the next video, we're going to start talking about randomized melodies, and we're going to be seeing a lot more of continuous patterns there as we delve deeper into how to make your overall structure of your song more random, more generative, and still having a lot of interesting variation and sounding good. So until then, have fun, keep experimenting with algorithmic music, and we'll see you in the next tutorial.